Let's do exercise number 1. Get ready with your calculator. Okay, get ready with your calculator and a piece of paper for you to do the calculation. Okay, right. So you don't have to worry much about doing this exercise because the result is given actually in the slide. You have the result already, but the only one that you don't have is the way how you solve the problem. Okay, to show the calculated answer. Okay, all right, let's look at this exercise 1. So this is a very simple one. All right, this is the basic understanding before you proceed to the advance of distillation process calculation. Okay, first of all, read the question carefully. So each sentences or each words can represent a very important data to you. Okay, all right. A liquid mixture. Liquid mixture. Okay, now you know it should be more than one component. Okay, and you don't know whether it is binary or maybe it is tertiary. You never know until you read all the words in the sentence. Okay, mixture, more than one component. Liquid mixture. Liquid mixture represent the condition of the feed. Okay, the condition of the feed is in liquid form. Okay, so if you refer back to this particular boiling point diagram, you have liquid form. Okay, where the composition that you have should be in liquid region. In liquid region. Okay. Next, a liquid mixture is formed by mixing a heptane, where we're going to use A as a symbol of heptane, and octane, symbol B. All right. So the next composition component that we're going to use the symbol of B. Okay. So we have component A and B in a closed container at constant pressure of 1 atm. So you have closed container, closed system, and the operating pressure is constant also, which is 1 atm. So the pressure is constant, but the temperature, the operating temperature vary. Okay, vary. Okay, because it just mentioned constant pressure. Okay, your job is to calculate the equilibrium composition. So based on the boiling point diagram that you have learned, you're going to get equilibrium composition at one equilibrium data at one particular temperature. So if you have more temperature, like what you have in this table, okay, but the pressure is constant, you're going to have a few coordinates, few points to give you the equilibrium composition data, which represent XA, XB, YA, and YB. Okay, so when you are to calculate the equilibrium composition of vapor, that will be YA for component A, YB for component B. And then for liquid, you're going to have to find XA for component A, XB for component B. Okay, all right. Okay, if you were to calculate the equilibrium composition of vapor and liquid, okay, you are to find this data. Yeah, XA, XB, YA, and YB. So you need to do manual calculation to get XA, XB, YA, and YB. Okay. All right. Next. Okay. If you were to plot a boiling point diagram of the system, okay, you can also plot the boiling point diagram of the system by having what? Okay, by having temperature and composition. Okay, temperature and composition. So this is how you get the boiling point diagram. So this is saturated liquid. Okay, then you're going to have to calculate the equilibrium diagram. Okay, so this is just exercises. Okay, just one exercise that you need to do to plot the boiling point diagram. Okay, later in future you just need to draw the equilibrium diagram only. Okay, all right. Okay, so what formula to be used here? Okay, you nak guna formula mana? Boleh siapa respond? How to find XA given the temperature and the vapor pressure of heptane and octane. Vapor pressure of pure component. So which formula that you want to use? Which formula do you want to use? Formula mana nak guna? Please respond. You want to use Rod's law? Or do you want to use Dalton's law? Or do you want to use formula number 1 here and formula number 2? Senyap kan? Formula mana nak guna? You are given the vapor pressure, you are given PA naught dengan PB naught. You are given that information already. You got given PA naught and PB naught.
Equation number 1, Court Miss.
So how, if you were to use equation number 1, you have the PB naught, PA naught. What about P total?
Constant pressure.
Constant pressure. What is the value of the constant pressure?
1 atm, which is 101.3 kilopascal.
Okay, that's good. So you can have that information. Okay, even though you don't have the partial pressure of A in vapor phase, okay, A in vapor phase or B at the vapor phase, but still you are given the operating total temperature pressure, which is 1 atm. Okay, you can use equation number 1 to calculate for XA. Okay, so what about YA? Can you use the same information? Do you want to use, to find YA, you need XA. Okay. You have PA naught already and P total. What about XA? Where can you find the XA? Where do you find the XA? Nurhanani. Nurhanani. Mana dia? Switch on your mic. Nurhanani. Okay,
Yes,
good. How to get your YA? Do you want to use equation number 2?
Yes.
Yes. Okay, if you were to use equation number 2, do you have PA naught?